Welcome to the Brain Decoded. Today, we're diving into the fascinating world of neuroscience to unravel one of the most fundamental processes in our brains, the action potential. Have you ever wondered how your brain sends messages so incredibly fast, allowing you to think, move, and feel? It all comes down to something called the action potential. To understand the action potential, let's first look at a neuron in its resting state. Think of it like a tiny battery, charged and ready to go. At rest, the inside of the neuron is more negatively charged compared to the outside. This difference in electrical charge is crucial for nerve impulses. This charge difference is maintained by tiny gates on the neuron's membrane called ion channels, which control the flow of charged particles, or ions. An action potential begins when a neuron receives a strong enough stimulus. This stimulus must reach a specific threshold potential to trigger a response. Once the threshold is met, sodium ion channels rapidly open, causing a rush of positively charged sodium ions into the neuron. This makes the inside of the neuron briefly positive. This phase is called depolarization. Immediately after, potassium ion channels open, allowing positively charged potassium ions to flow out of the neuron. This restores the negative charge inside the neuron, a process known as repolarization. There's a brief period where the neuron becomes even more negative than its resting state, called hyperpolarization. During this refractory period, the neuron cannot fire another action potential, ensuring the signal travels in one direction. Once generated, the action potential doesn't stay in one place. It propagates or travels down the axon of the neuron like a wave. Myelin sheath, a fatty insulation, helps speed up this process. The action potential is the fundamental electrical signal that allows our brains to process information, coordinate movements, and experience the world around us. It's truly the language of the brain. Thanks for joining us on the Brain Decoded.